Today we're going to look at how to solve equations using elimination. Now, elimination, like it sounds, is going to be eliminating one of your variables. So, for example, in this scenario, you can see on the two sides of the balance, and again, the balance represents an equation, two sides equal to each other. We would start with an equation like x minus 2y equals negative 19. And if you had another equation that said 5x plus 2y equals 1, adding this quantity to the left side and this quantity to the right side is the same kind of thing as adding just 5 to each side. You're adding the same amount to each side of the equation, so the equation stays balanced. But in the process of doing that, we will be eliminating or making add to 0 one of the two variables, leaving us with a one variable equation. So that's kind of the gist behind the idea of solving by elimination. Notice when we did this, one of the variables had to have opposite coefficients or they wouldn't add to 0. So when we solve by elimination, the basic process is going to look like this. You're going to want to make sure first that all your terms are aligned, including the equal signs. Then you're going to multiply one or both of your equations by a number so that you have variables with opposite coefficients. You may not have to do anything for this step if when you begin, you already have opposite coefficients. By adding the two equations together, we can eliminate one of the variables and solve for the one that's left. Then take the value you just found, substitute it back into one of your original equations to find the other half, and then write it as a pair and check your answer. So we're going to practice a couple of these. The first one right here, when I look at this and think about those steps, remember your first step was to make sure everything's lined up. So if you look at this, start by making sure your equal signs are lined up. My x's are lined up, my y's are lined up, my constants are lined up. So the first step's taken care of. The second step was to make sure that either the x's or the y's have opposite coefficients. And you'll notice right here that my y's have opposite coefficients, a positive 4y and a negative 4y. So my next step said to add the two equations combining like terms. So on this side I have 4 terms. These two are going to add up to 0. And so I'm left with 4x's equals, and on this side it adds up to 8. So by adding the two equations together, again, I'm adding this quantity on the left and this quantity on the right, and since those two quantities are equal, it gives me an equivalent expression here, or an equivalent equation. So then I'm going to divide both sides by 4 and get x equals 2. And now following those last couple steps, just like we did with substitution, I'm going to come back to one of these original equations and I'm going to replace the x value with 2 and solve for the y. So at this point I can subtract 2 from each side, get 4y equals negative 4, and then dividing by y get negative 1. Final step is always to write your answer as an ordered pair and check it. So I want to make sure it makes both original equations work. So I'm plugging back into the first equation and I'm supposed to get 10. 6 minus negative 4 is 10. When I plug into the second equation, I want to see that I'm going to end up with negative 2. And so when I plug in the 2 here and the negative 1 there, I get 2 minus 4 equals negative 2. So it made both of them work. This one, our first couple steps were already taken care of for us. It's not always going to be that easy. In this problem here, again, I'm looking at making sure first that my equals are lined up, and then on this side of the equation I have only constants, and on this side of the equation I have all my variables. The x's are lined up and the y's are lined up. My coefficients of x are identical, so if I were to add the two equations right now, I would actually end up getting 4 x's, not 0 like I want. And so what I'm going to do is I'm going to multiply one of the equations by a negative 1. So I'm multiplying my first equation by negative 1. That's going to change all the signs of everything in this equation to the exact opposite. My other equation I don't need to do anything to, but now I can add them up and this will add to 0 x's. So I've got my 0 x's here, a negative 1y, and a negative 5y makes negative 6y. And over here, 13 plus 5 gives me 18. So dividing by negative 6, I'll get that y is negative 3. Again, the idea here is that when I add the equations and I have opposite coefficients, I end up getting a new statement with only one variable. So I can solve for that variable, and then once I have that first value, I can come back to one of these equations and I can solve for the other variable if I replace the one I know with what I just found. So now I've got 2x plus 15 equals 13. If I subtract 15 from each side, I can get that 2x has to equal -2, and dividing by 2, I get that x has to be -1. Again, final step, go back and write it as a point and check it. It has to make both the first equation and the second equation true. So in my first equation, x is -1, y is -3. I get -2 plus -3 equals -5. And in my second equation, again, x is -1 and y is -3. I get -2 minus -15, so that's plus positive, and that gives me 13. So this solution that I found makes both equations true. That is what I'm looking for. Again, if we think of this visually, this would be the point where my two lines cross. I can find that point without graphing the lines. Notice this system right here. When I go to solve it, again, I could use substitution on this. I could very easily do that, getting this equation to say y equals, or this equation to say x equals. In all the problems we've done so far, we could have just as easily done substitution. Notice this one right here. Of all my choices, I wouldn't want to solve for this x because I'd have to divide by 2. Or here for the y, I'd have to divide by 5. I could, however, solve for this y. All I'd have to do is subtract the 2x and it's ready to substitute. But it was actually easier to solve by elimination. And in this problem right here, again, I wouldn't want to solve for any of these three variables because of their coefficients, but I could have solved this equation to say x equals and set it up for substitution. There are going to be times, though, when a problem that you look at, for example, this one right here, is set up in a way where you would not want to use substitution. If I were to try and solve this one with substitution, I would have to get this either solved for x, which would require dividing everything by -5, or I'd have to solve it for y, dividing everything by 2, which would lead a fraction here. Or in this equation, I'd have to divide everything by 2 to get this x alone, so I'd have a fraction here. Or I'd divide everything by 3 to get the y alone, so I'd have a fraction there. This one is not good for substitution. The other ones would have been fine for substitution, but this one is not good for substitution. Definitely would want to use elimination on this one. Let's backtrack here a second, though, because in this equation, notice, unlike the prior ones, here I just had to multiply by -1. But this one, I don't have these either opposite or same coefficients. So in order to get one of these to add up to 0, I'm going to have to multiply by something other than just a -1. So I can either get my x's to add up to 0 if I got this one to be 3x. I'd have to multiply the first equation by 3. So I would get 3x plus 6y equals 33. Make sure you're multiplying through to everything in this equation. If this statement is true, then 3 times this statement is still going to be true. Now I've got these opposite coefficients for my x's, and I can add my two equations together. My x's are going to add up to 0, and I'm going to have 7y equals 28, and so y will equal 4. And then just like before, I'm going to come back to my equations. I'm going to replace the y with what I know, and I can solve now for x. So I'm going to subtract 4, and that gets me to here. Then I'm going to divide by -3, and that'll get me there. Writing my answer as an ordered pair and going through and checking it, I see in the first equation that 3 plus 2 times 4, that's 8 plus 3 gives me 11, and that's what I'm supposed to get. And in the second equation, I get -3 times 3 plus 4, so I'm getting -9 plus 4, and that gives me -5, which I'm supposed to get. So again, verification, always take the time to check. This point is the solution to that system. Now the one that I want you to try, I'm just going to give you a tip here to get started, that I need to get opposite coefficients here for either x or for y. And when I start by looking at the x's, there's not a whole number I can multiply this equation by to get that coefficient to be a positive 5. And there's not a whole number I can multiply this equation by to get this coefficient to be a negative 3. So I'm actually going to have to multiply both equations by different things. And so I'm looking to turn them into their least common multiple, kind of like if these were denominators and I'm trying to get same denominators. So I can either get the x's to be opposite coefficients by trying to get them to say 10x and negative 10x, or I can get the y's to be opposite coefficients by getting them to say 6y and negative 6y. To get this, I'm going to be multiplying my top equation by 3 and my bottom equation by negative 2. To get this one, I'd be multiplying my top equation, I'll probably go negative on top, so the top equation by 2 and the bottom equation by 5. So it doesn't really matter which way you go. I tend to pick the one that uses smaller numbers, but in both cases here, the numbers are perfectly easy to work with. So I'm going to multiply this one by 3 and this one by negative 2, so that I end up with a negative 6y and a positive 6y. So this equation up here now, negative 15x plus 6y equals 96. And my second equation multiplied by negative 2 gets me a negative 4x minus 6y equals negative 20. Now that I've got these opposite coefficients, when I add the equations together, these will add up to 0. And so when I add here, I get negative 19x equals, and when I add these, I get 76. Dividing both sides by negative 19 gets me that x has to be negative 4. So if I take this value now and I find the other part by plugging back into the original, I can go through and solve for y. So I get 20 plus 2y equals 32. Subtracting the 20 from each side gets me 2y equals 12. And dividing by 2 gets me that y is equal to 6. And just like always, because even I make mistakes, we're going to check our answer. So I've got negative 5 times negative 4 plus 2 times 6 is supposed to give me 32. So I get 20 plus 12, and that one works, but one equation isn't enough. It has to make them both work. So I'm going to check in the second equation and see that 2 times my x plus 3 times my y is going to give me 10. So here I get negative 8, and here I get 18, and they do add up to 10. So now I know for sure that I got this right. Common mistakes that people make when they're doing these problems is multiplying through and forgetting to multiply something. So you might multiply this one by 3 and this one by 3, but forget to multiply that one by 3. Or maybe you're multiplying by a negative number, but you forgot that one of these was going to change its sign. And so maybe you wrote negative 4x and negative 6y and then positive 20. So if your answer doesn't work, start by looking for those things. Did you actually multiply each of your terms by what you meant to? And did the signs come out right? The next thing you're going to want to check is, did you actually add the columns properly? Because that's another place where a lot of people make mistakes. So if your answers don't work, make sure you check those things. So you should be well equipped right now to solve a system by elimination. Remember those steps that we went through here at the beginning? There were 5 of them. First, make sure everything's aligned. Second, make sure that you've got opposite coefficients. You might need to multiply to get that to happen. Then we're going to add the equations so that one of the variables cancels out, and then we can solve for the other one. Then we plug that number back into a 2-variable equation to solve for the other variable, and finally write it as a point and check. Good luck.